Did you know that there's over 2,000 species of rodents around today? That's more than double the next biggest group of mammals, which is the bats, and it's more than 20 times the size of the group that contains their closest relatives, which includes the rabbits, the hares, and the pikers. All told, rodents make up about 40% of all mammal species on Earth, and that makes them one of the most successful groups of mammals in existence. So, why so many rodents? What is it about them that makes them so abundant and successful? You know what I think? I think it's their skulls. In this video, we're going to be diving into the insanely over-engineered skulls of rodents. I'm going to be breaking down how their ridiculously effective teeth and uniquely adaptable jaw muscles have likely helped them to outmunch all other groups of mammals, fill a whole range of niches, and ultimately take that top spot as undisputed champions of mammal diversity. I'm Dr. X, welcome to the Skullywag Lab, where I present the bare bones fundamentals of skull science. Rodents, they're everywhere. Human history and culture, both fictional and factual, is plagued by their influence and symbolism. But in reality, they're not all filthy and gross. Some are really cute. Some are actually hyper-specialized to live in different environments, and some extinct species were the stuff of legend. So why are there so many species? Some of you might be thinking this could just be due to their ability to breed really fast, which would accelerate their evolution through faster generation times, sure. But lots of animals can do that, and they don't have anywhere near the same diversity, so there's got to be more to it. So could a crazy, hyper-efficient and adaptable skull have helped rodents get to where they are today? Let's run through some of the heinously overpowered features of rodent skulls and see if we can work out what makes them so successful. Let's begin with the obvious, shall we? Those bloody enormous and super specialised front teeth. These teeth serve as a kind of Swiss Army knife for rodents, allowing them to chew through all kinds of things. But how do they do this? Well, for starters, these things are a lot bigger than they look, often extending way back into the skull and the mandible. The reason these things are so long is they never stop growing, and they can grow super fast too. A rat's incisors can grow as much as 1 millimeter a day. That means the entire length of the tooth can be replaced in some species in as little as a month or so. Other animals can have serious health concerns if they chip or break their teeth, but not rodents. If they chip a tooth, they wouldn't have to wait long to replace it at all. So could these teeth be the reason for the success of rodents? On their own, probably not. There's plenty of examples of mammals that have evolved continuously growing in sizes. This includes elephants, hippos, hyraxes, wombats, and aye-ayes. If it was just down to having these teeth, we'd be swimming in wombats and lemurs of questionable attractiveness. So let's look a little bit deeper. There's something else pretty special about rodent teeth. The teeth of many rodents are laced with metal. Oh, I've got one here actually. Yeah, so have a look at this. This is the skull of a nutria, or a koipu. And if you have a look at the front teeth, there's this kind of orange-brown colour, and that's the colour that's often associated with high amounts of iron in the enamel of their teeth. Now, any influence that iron has on tooth colour has been challenged just this year, but this kind of pigmentation is nonetheless often seen in association with iron in the teeth, so let's stick with that for now. The exact role that all this iron plays in the teeth of different rodents isn't totally clear. It might help to increase tooth hardness or help resist damage from acid, excessive wear, or breakage. Maybe the reasons are different from species to species, but the fact that they have the ability to wolverine their teeth up as an adaptation at all is certainly an advantage. So is this the secret to the success of rodents? In itself, probably not either, because there's loads of animals that have the ability to lace their teeth with iron. This includes fish, limpets, salamanders, shrews, and even recently actually there was a paper showing it in Komodo dragons. But I can only think of one human. In fact, the iron-rich teeth of limpets have the highest tensile strength of any known biomaterial. They don't really use it for anything cool though, just for like scraping algae off rocks all day. Plus they don't really have a skull, so moving on. Alright, this brings us to probably the craziest part of rodent skulls, and that's the insane diversity of their jaw muscles. Alright, let's start with the most primitive arrangement, which is the most similar to other mammals. We can see it here in the mountain beaver. They have a fairly standard temporalis complex connecting the brain case to the top of the mandible, and an equally standard masseter complex connecting the cheekbones to that large section of the mandible down there. But there's two things we need to pay attention to here. The first is a specific muscle located on the inner surface of the cheekbones. It's called the zygomatico-mandibularis. No, that's not every letter in the alphabet. It's missing these ones. Let's just call this muscle Ziggy. Ziggy is often treated as part of the masseter complex and runs from the inner surface of the cheekbones to the mid-region of this part of the mandible. The other thing you need to recognize is this little hole here. It's called the infraorbital foramen. We humans have them as well. Pretty much all mammals do. The infraorbital nerve and some vessels run through here. The nerve provides sensation to the skin of the cheeks, nostrils, and upper lip. So pay attention to Ziggy and that foramen as we move along. Now let's look at the first set of crazy muscle enhancements. We can see this in a squirrel. Notice how they have a similar arrangement of the temporalis, but the masseter complex has this huge expansion forward stretching across a decent chunk of the face. This anterior movement of the muscle increases the leverage of the lever system. Basically, it allows more muscle force to be converted to bite force, permitting stronger bites. You can see more about this in a previous video linked at the top right corner. So in this formation, Ziggy has a pretty normal place behind the cheekbones, just like in the mountain beaver. The foramen is also small and normal looking here too. Biomechanical analyses have shown that this arrangement is better for incisor gnawing, and that makes sense because squirrels spend a lot of time chewing away on nuts and seeds. Now let's move on to the second set of muscle arrangements. We can see this in the guinea pig. Temporalis complex stays pretty standard, and the masseter complex stays pretty similar to the mountain beaver. But holy cheeses, what's going on here?
What?
Ziggy has way more space for attachment inside the cheekbones, but has also expanded through the skull to connect further forward on the snout as well. It finishes up in a similar position to the masseter on the squirrel. For this to be able to happen, that infraorbital foramen needed to expand massively. So rodents with this configuration have a huge pair of holes in their skulls, just in front of the eye sockets. This arrangement is better for chewing with the molars, so it might be more useful for herbivorous diets. This would explain why the skulls of many of the largest species of rodents to ever exist show this exact configuration, and either are or look to have been herbivores. This includes the capybara that's around today, and the extinct bull-sized rodent Josepho artigasia. For the third type, let's look at the humble rat. Again, same kind of temporalis complex, and this makes sense really because it only contributes about 20% of the total muscle force. But this time there's shifts in both the masseter complex and Ziggy here. The masseter extends forward like in squirrels, but Ziggy also stretches through the foramen out onto the snout as well. This means they have a combination of both approaches, but with neither as extreme as in the other two groups. Nevertheless, this combined type means there's two possible muscles to tinker with through adaptations to biting, and it's been suggested that this configuration might be the secret to the success of rats, mice, and other rodents of this group, which have the highest numbers of species of all rodents, at nearly a quarter of all mammals. It's almost like if the squirrel masseter is a fork, and Ziggy and the guinea pig is a knife, the rat has both a knife and a fork that can be adjusted over time to a broader range of feeding tasks. And on top of all of this variation in the teeth and the jaw muscles seen across rodents, different species can also have additional feeding adaptations that are more similar to those seen in other mammals as well. Have a look at this video up here that I've done previously that identifies some of those, but I might do another video of them specifically on rodents in the future. Okay, so we have continuously growing incisors. We have the ability to reinforce those with iron for various purposes. We have a high degree of modification to the jaw muscles and changes to the skull that help accommodate those. And all these features together have undoubtedly helped rodents to spread across the planet. But you know what? I don't think it's all sunshine and rainbows. If these teeth aren't constantly worn down and the teeth become too long, they can cause all sorts of problems, including ulcers and misalignments. In extreme cases, it might stop them being able to eat altogether. So how do rodents avoid this? Well, they need to file those teeth down. And keeping those teeth in check is a never-ending task. Some rodents will brux, a term for grinding their incisors together. Others will gnaw on things. Constantly. And what they decide to chew on might not always be nutritious and edible, but just things to help them wear their teeth down, and sometimes to give them access to new places too. Mice can chew their way through wood, plastic, vinyl, and aluminium. Rats and mice can gnaw through thick cables, sheet metal, rubber, and fiberglass. Rats can even chew through concrete. They don't necessarily use high bite forces to do this either. Every time they gnaw away at something, it's a war of attrition, and most materials do eventually succumb. But if an animal weighing only half a kilo, or a few pounds at most, can get through concrete, what else is there to achieve? Oh my god, listen to that. Sounds like my Year 10 woodwork class. So it's this willingness to chew on all kinds of things that might make it easier for them to find different foods and diversify into different niches. This could help explain their crazy species diversity. That's not peer-reviewed, by the way. I just thought of it myself. I ran the idea past Associate Professor Philip Cox of University College London, and he's a world's leading expert on rodent feeding biomechanics, and actually a lot of the theory I've talked about in this video has come from his papers. And he said he hasn't heard this idea that their gnawing behaviours might have helped them to discover new food sources and ultimately maybe fall into new niches, but he likes it. So I like it. There you go, you heard it here first.
That's illegal? Very illegal.
In reality, there's probably no single reason why rodents are so successful. It probably comes down to a combination of factors that have worked together to create this perfect storm of evolutionary badassery. This can include small body sizes, short generation times with the ability to produce a lot of offspring, generalist, unspecialized diets, and yes, overpowered skulls. The fact that they have all these options in their evolutionary arsenal has undoubtedly given them a winning hand, and the proof is in the pudding. They're everywhere, and they're not going anywhere anytime soon. Catch you in the next video.